So for question 1, a letter is chosen at random from the word homework. We need the probability of picking the letter O. First of all, we need to count how many letters there are in the word. So 1, 2, 3, 4, 5, 6, 7, 8 letters, and 2 of them are the letter O. So our probability of choosing the letter O is 2 out of 8 altogether. And we can simplify that down to 1/4. For question 2, take your time to understand the question first. Read what the information that we're given, take your time to look at the diagram before we attempt to answer it. First of all, the universal set, that's everything inside the rectangle, contains letters from the word trapezium. Let's check. T-R-A-P-E-Z-I-U-M. So all of the letters from the word trapezium appear once in the Venn diagram. Set 1 contains the letters of the word prime. Let's check. P-R-I-M-E. And set 2 contains the letters of the word term. T-E-R-M. So we can see all this information at the top here shown clearly in this Venn diagram. We're then told a letter is chosen at random from the word trapezium, i.e. from the whole of the universal set here at random. What is the probability that the letter chosen is in both of the words prime and term? Okay, we can see the letters that are in both words are in this overlap, and R, E and M appear in prime and term. So we want how many letters appear in this overlap in both words out of how many altogether. So we have 3 letters in both of the words out of 1, 2, 3, 4, 5, 6, 7, 8, 9 letters altogether. So our answer is 3 out of 9, and we could cancel that down to 1/3 if we wanted. Question 3. The frequency tree gives some information about how 100 children travel to school one day. So we can see we've got 100 here representing our 100 students, and it's split into boys and girls. We need to complete the frequency tree. So we've got some missing numbers A, B and C. So if there are 100 students altogether and 54 are boys, then the rest of them must be girls. So here we're going to work out 100 minus 54 to give us A, and we'll get 46 there. So A is 46. Now boys and girls add up to 100. If I come up to the boys section here, we've got these 54 students. They either take the car or they walk or other mode of transport. The walk plus other comes to 29. But altogether, we've got 54 here. So we need here to work out 54 minus 29 to find B. If I'm subtracting 29, what I can do is subtract 30 and then add 1 back, and that will give me 25. 54 take 30 is 24, add back 1, 25. So B equals 25. I come down here to the girls, and I've got 46 girls. At the moment, I've got these 3 numbers need to add up to 46. So 8 plus 16 is 24, and I need to do 46 take away 24 to work out what C is. So 46 minus 24 is 22, and that goes in there. As a final check, you can just check that all of this column here adds up to 100, 25 plus 15 plus 14. So that'd be 25, 30, 40, 54 here. And here, 8 plus 22 is 30, plus 16 is 46. So 46 here as expected. And then our 54 plus 46 adds up to 100. Question 4, again, take the time to read the information given up here and then look at the tree diagram, make sure it makes sense. So Lauren has 2 bags. The first bag contains 3 red and 2 blue. The second contains 2 red and 5 blue. So if I now look at the tree diagram, I've got my counter from the first bag is either red or blue. And then my counter from the second bag is either red or blue. I've got different numbers of counters in each bag. So my first bag, 3 red and 2 blue, I've got 5 counters altogether. So the probability of red is 3 out of 5. My probability of blue here needs to be 2 out of 5. So A here is 2 out of 5. If I go back to my second bag up here now, 2 red and 5 blue, so there are 7 counters altogether. I can see we've already got filled in the probability of red in the second bag is 2 red out of 7 altogether, so 2 sevenths. So now I can fill in B, must be 5 sevenths. Now, it doesn't matter what counters I took from the first bag, the second bag has those 7 counters in, and the probability of red or blue from the second bag is exactly the same as regardless of what counter I took. So for C, the probability of red in the second bag is just 2 sevenths, and the probability of blue in the second bag is that 5 sevenths. And we've completed our tree diagram. In question 5, ABC is a right-angled triangle, I'm giving it there, and we need to calculate a side length, the length of BC. Now, when I see a right-angled triangle, we need to be thinking it's either Pythagoras' theorem or it's trigonometry SOHCAHTOA. Here we have no angles involved in the question, it is purely the side lengths, therefore it is Pythagoras' theorem. I'm going to explain this in 2 ways, it depends which way you've been taught. There's a kind of shortcut method. Here we are finding a shorter side. The hypotenuse is 16 centimetres. So in our sort of quick method, if I want to find the shorter side, I need to square and subtract and then square root. If I were to find the hypotenuse, the longest side, I would square and add, then square root. So in this sort of quick method, square and subtract, then square root. So I would do 16 squared minus 6.7 squared. You type that into your calculator and you'll find 211.11, 211.11, and then I want to square root that, 211.11, and you could just do square root answer, and we get 14.5 correct to 1 decimal place. Now, if you've been taught a more formal method, we would start by writing down Pythagoras' theorem in looking for the hypotenuse first, 16 squared. So here I would write down 16 squared is equal to my BC squared plus 6.7 squared. This is Pythagoras' theorem. The hypotenuse squared is equal to the square of the other 2 sides added together. So you might recognise this as C squared equals A squared plus B squared, where C squared is the hypotenuse. Okay, if I'm now trying to solve this, I would be doing 16 squared minus the 6.7 squared equals BC squared. So there's my 211.11 is BC squared, and then I can see this is why I need to square root. Square root that, and I get the same answer. So whichever method you're comfortable with, the shorter method or this more formal method, it's 14.5. Question 6. So a rectangular television screen has a width of 45 and a height of 34. So we read the words, we check the information is shown in the question, add anything else that we can. Now the fact that it says rectangular means that this has to be a right angle. Work out the length of the diagonal. Now you can ignore everything else in the picture. Basically what we've got here now is a right angled triangle. The bottom length is 45, the height there is 34, and we want to find the diagonal. So again, it's Pythagoras' theorem, and here we're finding the hypotenuse. So we can use our short method, so quick method for longer side, for the longest side, which is the hypotenuse. This time we square and add, and then square root. So here we would do 45 squared plus 34 squared. We type that into our calculator and get the answer for that. And that gives us 3,181. And then we want to square root that, and you can just type in square root and then answer. And we get 56.4. Now it asks for the nearest centimetre, so it's going to round to 56 centimetres. And then just clarify nearest centimetre as asked. Okay, formal method. If we're starting with, it's all the same steps, we're doing the same maths, it's just how you lay your work out that might be different. The formal method is the hypotenuse squared is going to be equal to 45 squared plus 34 squared. And actually to solve this, to find h, we just square root. So you can go square root 45 squared plus 34 squared, and you can type that all into your calculator all in one go, and we'll get the same answer there, 56 centimetres to the nearest centimetres. So it depends which method you've been taught and what method you're comfortable with. Either is fine.